So, welcome to the final class of the Joy of Programming. And final class taken by me. I'm not sure if any of the other TAs will be taking class this week after this. But as a final class, this will be a little shorter. This will only be 1 hour. And we will just go through almost everything we have taken over the entire course. Like, I first thought I'll write some code to show all the different things, but by now you should be familiar with the basics. And unless you have a specific question, uh, please mute yourself. If you have a question, feel free to ask me. I'm always glad to answer questions, but uh, please do mute yourself if possible. Okay, so since you're starting from scratch, we know that Python is an interpreted programming language, and when you talk about programming languages, the first thing we need to learn are about variables. But before we properly went into Python and variables and functions and all those, we first talked a little bit of Anaconda, how to install Anaconda and the different things like that. Like, to be fair, I always would recommend that you save a tab on how to make or get started with Anaconda, because every now and then you'll open a new computer and wonder why the Python is not working, and at that time, if having Anaconda tips is like kind of convenient. One thing is, when you're installing things with Anaconda, do remember that you need to use the Anaconda prompt to install specific Python stuff. Like if I want to conda install torch, I think that's a thing. Yeah, you can only do this inside the Anaconda prompt, because otherwise uh, the things are not valid. Oh, fortunately torch is not a thing, otherwise I've installed it, thank goodness. Anyways, after that, we have to go to the basics of Python, and we do that by first learning about the variables, how variables are and how to interact with variables. So the first type of variables we see are the basic ones: integers, integers which are just numbers like 42, 69, 169 and so on. Floating point numbers are anything with a decimal point like 3.141527 and so on, and the variable e and things like that. Essentially, if there's a dot anywhere inside, it'll probably be looked at as a floating point number. And bool stands for true and false, true or false. And these three are essentially the main basic data types. There's strings also, but I've considered strings along with lists for a specific reason. Now, in addition to the basic data types, we also know that there are functions like print and input. Those are like very vital functions for beginners, because we always have to print our output. We always have to take an input from a user. In later classes, we learned of other ways to get inputs. For example, we can open files to get inputs. Otherwise, you can open a website to get an input and things like that. So while input is a very useful function, it's not always used for all practice. Give me a second. It's not always used for all. Yeah, it's not always used in every case. So with input we can get these values and so on. Now, what are the things we can do with integers? We can do most operations that we capable of. We have usually we are aware of, like adding, subtracting, exponentiation, and things like powers. Oh, I repeated stuff and so on. There are other operations also, like bitwise operations, but those are kind of complicated topics, and I'm not going to talk about them now. After that, we talk a little bit about the more complicated types of data types, the compound data types. The lectures talk about strings, lists, and dictionaries and sets, and do not talk about classes. But I'll just quickly once again talk about give me a second, I'll answer that question in a while. I'll answer what I know about that question in a while. So strings, lists. Okay, honestly, I should put list strings here. This is a disaster. Okay. Strings are kind of basic data types in the sense you need strings for many things, and knowing how strings work properly and the different kinds of strings is kind of important. My favorite kind of string is the F string because it allows us to very nicely write substitute variables inside the F string. For example, things like this just work out incredibly nicely with F strings. Raw strings are also fundamentally needed because when you're working with file paths and things like that, we need raw strings. And multi-line strings are essentially strings which take multiple lines. See, like in a normal string, you cannot have multiple lines, right? Okay. So about the question paper pattern, it should be written as the problem solving sessions. I'm expected to solve questions, and we are not told about how the questions will be. So the best bet for the question paper pattern is to ask in the discussion forum. Like we have been told to direct you there in case for the more administrative questions. Is that fine, Seshu? I guess it's okay. Okay. So then we talk about lists, dictionaries, and things like that. Why? Okay. Lists are one of the most important things we have done in Python. We have done so many questions which involve lists. For example, the first many programming assignments essentially just use lists, dictionaries, and things like that. I don't have like statistics of how many questions we use lists and dictionaries, but like the first question is a dictionary question. The second question was a list question. Yeah, and things like that. So you might wonder that whether you actually have you actually find just questions like this in real life, and you'd be surprised. It's kind of true. Like very recently, I had to write a small program to extract data from a couple of websites. So with I just wrote a quick example of how it looks like. So I wrote a function to access the website, and I used an F string because all the websites I had to access had a very what's that thing called? Had a common pattern in the websites. After I open the website, I extract the information I need from the website into a list, and then I use the normal text, used what I needed from that list. So yes, in lists, dictionaries, and things like that, even though they seem fundamental, they are incredibly useful for most programming questions. The reason lists and dictionaries and strings can be used so effectively is because they are a concept called iterators. Iterators are things which you can put in a for loop. For example, I can say for letter in A, print letter. What this will do is it will take it for letter in A will go through the string letter by letter, and I can print the letter if I need. So I think this is a nice segue to functions, because functions are just as important as variables in Python. Functions are essentially used in case we have to repeat a lot of operations and things like that. For example, if I want to check if something's is a vowel or not, that is a quite useful function, right? So we can just write a function is vowel, which takes an input and gives us an output. So if the way I'm going to check is I'm going to compare it with all the vowels. Uh, 218, from what I understood about the exam pattern, they might not ask you to write a program. I mean, I would defer you to the forums once again. Like, if you have questions regarding Python, you can ask, but I'm not familiar with the exam paper pattern and things like that. So one way to check if something's a vowel, we can just check if it's in the list of vowels. But just to make it nice, we can put it inside. We can make it check all the lowercase characters only. Return. So what are functions? Functions are essentially things which take an input and give us an output. If before some of you point out, yes, we can write this in a more short and concise manner, but I just wanted to explicitly show how it's doing the calculations. So the thing is, functions can get a little tricky at times. So let's just go back to the previous thing. So this function just checks if S is a vowel or not. So I want to print the values of A if it's a vowel. So if is vowel of letter so with this, I am extracting all the values inside this is a string, taking 2 lines, and only printing it if it's a vowel. That's I could have put this inside the if statement here directly, as in if but it's not always the case that the function is as simple as this. There is one pitfall when it comes to functions, and that is when functions take lists, dictionaries, or classes as inputs. If they take strings, integers, and floats and bools, in general it works perfectly as you expect. But sometimes you can do things incorrectly if you take an input of lists and things like that. If I say a is equal to 1, 2, 4, 3, and I define a function whose input is a list, and I count the number of elements in the list. Yes, we have a function for that, but I'm just trying to show an example where things can go wrong. So let's just say k is equal to len of a. So let's say I wrote the correct code for most case, but I accidentally made a small mistake in my code, and now my function is changing the list. If I'm remember, the idea of a function was that it's a singular block of code which does not affect anything else. So as in, I can just keep running the same function again and again, and it should give us the same output. So print get count a. So in cases like this, we see return k. In cases like this, because the function is changing the input, what happens is the original list is also changed. I and a couple of other TS probably have mentioned this. This is because the way a function takes an input has two kinds. A function can take an input by value or by reference. When I'm saying taking things by value, it means for example, if I'm taking a number, if I'm making, okay, for example, in this case, the function is taking the value of the letter by value, because letters are very well defined numbers and things like that. Like letters are not complicated data types, but lists can be a little complicated. For example, if a list has 1,000 elements, it's very weird for the list for a function to copy the entire list, and that's not nice. So in that case, we use the function takes things by reference. Because it's taking things by reference, you should be slightly careful when you write functions use that whose input is our list or dictionaries or classes, because you can accidentally make a small mistake and ruin your data. For example, yes, a better example is, say you want to find the largest element of a set, largest element of a list. So I'll write get largest. It takes a list, I sort the list, and then I take the largest element. The issue with this is every time I run the code, whenever I run this function, the list A will change. So if I have q is equal to 1, 4, 3, 6, 9, 2, 2. Print q, print get largest of q. So in this case, all this function is supposed to do is get the largest element from the list. But after I run this function, what happens is the list has changed. The list is sure, the values in the list are the same, but there are times that you want to preserve the location of the elements in the list, right? So essentially my point is functions are of two types, and function inputs can be of two types, and you must be careful when the function input is a list or a dictionary, because you could accidentally do something which can change the input, and that can have undesirable effects later. Now back to the point about iterators. Iterators are essentially anything that you can put in a for loop. Lists are an iterator. So I can put for item in queue, print item. What this does is, since list is an iterator, what does an iterator mean? It means I can go one by one over every element of the list. So when I do for item in queue, the first value of item will be the first value of queue, and so on. This concept of iterators is like incredibly powerful, and Python allows you to write your own iterators. I will talk about classes later today if you guys want me to. Essentially, classes are a mixture of everything you have seen so far. Classes are essentially a type of a more complicated data type where data and functions are together, and that's separate for now. You guys have seen classes. For example, a list is technically a class. If I do q dot, I get all these functions, and that is because there's a class for what a list is. Essentially, a class is a way you can write your own things like this. After this, we saw a lot of ways on how to do read files. Like you can do with open some file name. So week 4. So some interesting things you can do with Python is you can technically open Python files as text and read it, and you can do more than just read with, so printf dot read. So apparently this is all I've written in the week 1 class. Interesting. Okay. So like one weird thing we can do is, I'll just make a variable s is equal to string s string replace. Oh yeah. So this might seem like a very trivial thing, but essentially what I've done right now is I've read my week 1 file, stored it in a list, and then I replaced every value of a with q. So now I can save this as a .py, and once I save this as a .py, I can run that Python file. So technically, you can quite easily make a file which reads a Python file and changes that Python file. So in that sense, Python is incredibly powerful. Like you can do so many things that you otherwise would like take a lot of time to write out. Like say you want to copy your friend's assignment. I'm not suggesting you do, but say this is one thing you can do to like make the files completely different. But you do notice you have to do this in a slightly smart way, because if I just do a careless replace like this, even the comments will become a little weird. So that's about file manipulation. After file manipulation, we talked a lot more about functions. So there's one specific kind of function called recursive functions, which I felt very important, and it was eventually taken, I think, in the course. And naturally the example we give is the Fibonacci sequence. And if you see week 5's lectures, you will see how I try to optimize this algorithm using dictionaries. Give me a second. So I am sorry, Shalom, but I've not been told what the exam paper pattern would be. So like right now they expected me to like solve questions in class and things like that, So I was thinking of spending the first 30 minutes explaining the different concepts we have done last week, and then finally looking towards the end of the last 15 minutes, I'll solve questions I have. Otherwise, if you want me to solve questions, I can solve a couple of questions that you want me to solve. We've been told that what I've been asked to do is conduct a programming a live programming class, and not like administrative things like this. I hope that answered your question, Shalo. Okay, so we've talked about functions now, and now we'll go through a little bit of the more useful modules we have done in the course. So if you are doing any serious mathematical operations, the NumPy library is an absolute must. Like essentially, NumPy has includes a lot of optimizations for you to do a little bit of maths. If I'm honest, Python, there is a meme on the internet that Python is incredibly slow, and unfortunately, it is correct. In comparison to many other languages, Python is slow. But you can use NumPy libraries and things like that to make it slightly faster when it comes to doing things in maths. Now, but other things that you'll probably want to do is to make plots, and for that, the Matplotlib and Seaborn libraries are incredibly useful. I think in week 6, or was it week 7? Maybe it's week 8. Yeah. So in week 8, we use the Matplotlib library to analyze text and make a plot out of it. So if you want us to go over this again, sure, we can do that. So but feel free to ask. The NetworkX library, I've personally not needed to use this as often, but it's very useful when it comes to working with graphs. And I believe that I feel like the course lectures did an excellent job in trying to teach the NetworkX library. I personally use the Selenium library more often because browser automation is so fun. You can do so many things if you're because the internet is like so vast. You can do so many things with browser automation. So one interesting thing is many sites allow for APIs, and technically you can do access those APIs with Selenium also. What is an API? An API is an application something interface. The P is trivial. The thing is, for example, one site I quite often use is Photopea, and Photopea allows you to, it's essentially Photoshop, but open in folder, trivial in file explorer. Photopea essentially is what's that thing called? Photoshop, and you can, I think I crashed it. Okay, no. You can essentially do a lot of things you want to do with Photoshop on Photopea, like make new layers and layer via copy and things like that. So the thing is, Photopea has an API. Where did it go? Photopea has an API, and the API is essentially just accessing, doing things like this. You give the files in certain ways, you give the resources in certain ways. So with Selenium, you can even automate things you want to do in quite a few sites. In fact, if you want to get a lot of data, yes, Vishwananda, you can get the previous classes. So if you go to the Swayam portal, all the way at the end of the thing, we have problem solving session. If you click this, you'll be able to get what's that thing called? Yeah, a Google Sheet with all the YouTube links of all the classes. I hope that clarified your question, Vishnad. And you should have access to each of these. So, okay. So, as I was saying, this is why I use Seleniums. Like, it's incredibly powerful. The Pillow library and OpenCV library, they are like, if you're going to be doing object detection and things like and image manipulation, these are a must-have. Some other libraries which could be useful. Yeah, I'm glad I could help, Vishwa. I hope it's okay. Some other libraries which I felt were useful is tkinter, which helps you create actual Python GUIs. GUI is essentially a fancy word for GUI is a graphical user interface. Like, this is a graphical user interface. I don't. Why do you do this to me? So the other class, we made a small Python GUI for making a small calculator. It doesn't work perfectly, but you can type numbers in, and well, it doesn't do anything other than typing numbers in. You can add the functionality of making the operators work also later. And for this, we used a small one small thing we had used was the concept of lambda functions. Like, functions are cool, but the thing is, they are a little verbose. You have to write a little bit of things for functions. Oh, this is the wrong one. Like, def name of function input cal return thingy. So in general, if you have a very simple function, it's a little awkward to write all of this like in 2 lines to define the function. So sometimes you just want to write something called a lambda function, and essentially you start with lambda. So for example, let's take a function which squares its input. So these two things will do this. These two control X. These two cells do the same thing. As in, name a function is now a function which just like squares the input. And some people might find this so much more convenient than this, and therefore you can just use lambda functions in that case. The true power of lambda functions are because Python allows you. Okay, give me a second. When I earlier talked about Python functions take an input and give you an output. And the input can be anything. It can be lists, classes, integers, strings, anything. But another thing a Python function input can be are other functions. You can make a function which takes a function as an input, which is quite wild if you think about it. it takes a little bit of time to properly understand how this works, but with practice you can get it to work very fine. So in cases like this, where we have functions which take other functions as inputs, then lambda functions are incredibly powerful, because in my example last week, we had to for each of the buttons, we want it to do something different. Like if I'm pressing 6, I want 6 to pop up. If I'm pressing 8, I want 8 to pop up. So the hardworking way to do this is to define 10 functions, one for 7, one for 8, one for 9, and so on, which is a little too much work for me. So instead, we use lambda functions to make this a lot faster. And then we talk a little bit of classes, and yeah, so that essentially covers everything you've taken in this course. I've marked classes in red because you have technically not covered classes, but you have implicitly covered classes. So are there any questions you want me to try solve? Or can I just continue with other kinds of questions which I have made? Okay, so yeah, I think I forgot to mention this. Okay, so we'll continue with our questions. So some of the questions which I first thought we'll do some of the old programming assignment questions, because we never actually looked at them. Point exclamation. For example, in week 5, the programming assignment was, we are given a list L and you have to write a does someone have a question? I heard some noise. Okay. In the week 5 programming assignment 2, the question was, we are given a list and you must identify the unique elements in the list. There are a few ways to do this, and this might not be the optimum way, but the way I had solved this was to make a dictionary. So I made a dictionary called number of elements def unique. Now I go through the elements of the list one by one. For element because list is an iterator, we can do things like this. Now if I get an element, I need to first check if it's already inside the list. If it's already inside the dictionary. So for that, I'll check if element in number of elements, that this means if it's already an element of the list, I can just increase the value of that thing. Number of elements of element otherwise, this is the first time I'm coming across this element, and then I'll set its count to 0. To find the number of unique elements, essentially now I need to just find which of these elements have the number of elements equal to 1. is it possible to look into the work files which you have done through GitHub? The way I would recommend is to use it with GitHub. So you can go to my thing here, and you can use GitHub to download every files and things like that. Abhishek, you can read the question above. I mean the facts. The discussion forum will be here, right? Give me a second. Yeah, here. Ask a question. If you click the ask a question here, it will take you to a Google group, and there are a couple of people have already asked the question, like what the exam paper patterns and things are. So essentially you go to the course and click ask a question. Nishikant, is that fine? Okay. Yeah. And Vishwa, you do you want an explanation on how to use Git, or is it fine with you? Like essentially there are two ways you can do it. Okay, that's good. Yeah, like knowledge of how to use Git properly is, like, I personally feel it's like very important if you're learning programming. So yeah, okay. Now we'll go back to this. Now one way we can do it is using, we can just return a value using list comprehension. Pallavi, look how much questions come from assignments. As I talking about the exam paper tomorrow, Pallavi. So Pallavi, for questions regarding the exam paper, please look at the fact. I'm sorry, I've not been informed about what the exam paper patterns and things are. Yeah. Hopefully this works. How do I sort it? Well, it's working, it's just not sorted. So like if you just if you put the values which are given in the question paper, this is one way to do it. Do you guys have any other ideas on how this can be solved? So here I have explicitly written the number of elements. Let me see Kamala solution. Yep, that also works. That's a very neat solution using many of the uh, many of the list methods in Python. And frankly, one of the best ways to do list methods in Python is, one of the best ways. Sorry, give me a second. Like, people talk about writing Pythonic code, and in general, writing Pythonic code involves using the default functions as much as you can. So yes, Kamala's solution is quite decent. Yes. What like one program which I had seen a couple of years back uses the random library to estimate the value of pi. Let's set n is equal to 100. So what we do is essentially we first construct a small grid. And we generate two random numbers from this grid. Because we know the center of the grid, we can and we know, so given a point inside, let's consider this point, and that point is x comma y. So I'll just keep randomly generating random values x comma y, and if it's inside the circle, I'll increase a value. If it's not inside the circle, I'll not do anything. So count by area of the square is 4, area of the circle is pi by 4. Yeah. So as you increase the number n, you get closer and closer to the value of pi. But because it's random, you can keep doing it and it will keep giving you different answers. Yeah, so this is a kind of an interesting problem I'd seen a long while back, which shows how to use random numbers to do quite kind of interesting calculations. Like specifically, this is called I forgot the name. I think these are called stochastic methods. Omkar, read the fact. I'm sorry, but Oh, we have not been. I have not been informed of this yet. So it might do you. It might be better if you look into the discussion forum. Yeah. So now there's just like 5 more minutes. So if there are any specific questions, like as this was a shorter class, I could not go more in depth about a specific library or anything. So I decided just to do a quick introduction, quick recap of everything that was done so far. So I'm guessing there's no. So if there are no more questions, best of luck for your exam. I hope you guys do well. And even though this is the end of the course, I do hope you guys continue learning Python. There are plenty of new things coming in Python. Python 3.12 kind of just released, and it's kind of nice. It's kind of incredible. And I hope you do keep in touch with Python.
If required, can we contact sometimes? You even after exam?
I believe you have my email ID should be accessible. Otherwise, you can. Oh, you can do fancy things. Like if you have any questions, you can ask me via an issue in GitHub. Just kidding. So my email ID will be here. I'll just write it. So if you have any questions, I mean, I yeah, you may ask me questions like this. Yeah. I'll upload this week's lectures also to. So that kind of concludes the class. I hope you had a. I hope you've learned things in this course. Why are people still joining? It's still 6, right? Yeah, the class is still 6. Okay. So, yeah. Have a great week ahead. Best of luck for your exam. Glad I could help. Yeah. So if you have any questions, sure, you guys can just send me an email, I guess. But question regarding Python. If there's any question regarding how the exams are in
You
the
can
quiz.
share your mail ID through chat box, sir.
Okay, I was thinking that you will have access to the file in GitHub anyways. Yeah. So I'll stay around for 5 more minutes. So, and for the YouTube audience, have a great week.